right, I wanted to make a correction here. I mentioned it was posit 3-4 before in the slides, but it's actually theorem 3-4. And this is the converse of the corresponding angles theorem. So I had it as a theorem there, but wrote the word postulate. All right. So now let's look at an example that where we're using our new theorems. Okay. So our new theorems, if we can prove that corresponding angles, alternate interior angles, or alternate exterior angles are congruent, we can prove that two lines are parallel. Or if we can prove that same side interior angles are supplementary, then we can prove that two lines are parallel. And that's what's happening in this case, right? We have same side interior angles here, right? They're on the same side of the transversal on the left, and they're both in between the two lines that we're trying to prove that are parallel, okay? And so it's asking, what is the value of x for which A is parallel to B, right? For these two lines to be parallel, what does x have to be? And we know that these would have to add up to 180. They have to be supplementary for the two lines to be parallel, right? So we can say that 2x plus 9 plus 111 has to equal 180 for A and B to be parallel. And by the way, we could put parentheses around the 2x plus 9, but we don't need them. There's nothing in front here. We're not distributing anything, and so I'm just going to leave the parentheses out. We can combine like terms here. So we get 2x plus 120 equals 180. Subtract 120 from both sides. And so we get 2x equals 60. And when we divide by 2 to isolate the x, we get x equals 30. So that's the value for x that would prove that A is parallel with B. All right, similarly, number 3, what's the value of W for which C is parallel to D? Okay, so we have to identify, okay, what kind of angles do we have here? What type of angle pair is this? So these two angles are both in the same position in their respective intersections, right? So they're both in the top left position in each of their intersections. And so those are corresponding angles, right? So corresponding angles are or must be congruent in order to prove that the two lines are parallel, right? So we can say, okay, well, 3W minus 2 must equal 55. So that's our relationship that we can set up, and then we can just solve for W from there. All right, so this is using theorem 3-4. By the way, the corresponding converse of the corresponding angles theorem. Okay. All right, so I'll let you solve for W, and because at this point, simple algebra, so we'll move on to the next example. All right, number 5, find the value of x for which m is parallel to n. Okay, so if these two lines are parallel, then what would the value of x have to be, right? So here we have two transversals. We have this transversal, right? And in that case, angle 4x and angle 119 are not any particular relationship that's helpful, right? They're not alternate interior because 119 is exterior, and since 4x is interior, they're not alternate exterior. They're not corresponding. They're not in the same position, and so we don't have those relationships. But we could pretty easily find this angle here, right? Because we have a linear pair with 119 in that angle, and then 4x in that angle would be corresponding. So that would probably be my suggestion. We also have a vertical pair here, so we could find that would be 40 degrees, and we could take that avenue. But I think this will be the easier way to go. So 180 minus 119 is 71. Okay, and so So what we can say is we can say, well, 4x must equal 71 degrees by the converse of the corresponding angles theorem, right? And so then we can just divide by 4, and x must equal 71 fourths. All right.